Hello, Professor Blythe. This is Yan Zhao and Riley's final project presentation. In this presentation, we will include three parts: optimal portfolio, campaign, and vector model analysis. In the optimal portfolio project, we use efficient frontier to rebalance the portfolio week by week and analyze the portfolio's performance by using different ratios. In the campaign model, we use campaign and other model to derive the betas. In the vector model, we use vector model and French pharma model to fit the model and derive betas. The first project is optimal portfolio. Our portfolio consists of 20 risky assets with 500,000 initial value and a 1-year US Treasury bill with 500,000 initial value. So the table lists 20 risky assets. And by using efficient frontier, we change the weights week by week. We can see that the change is not so large. And for assets GE, it changes from positive number to negative number on week 5. This is because the stock's price changes a lot. And for other assets, the weights keeps the positive or keeps the negative for VLU assets. And we also record our net liquidation and portfolio value. And here, the net liquidation value and portfolio value changes slightly from week to week. We change the scale of y-axis to make it more clear. The overall trend is increasing from week to week, especially the slightly decrease of values on week 4. And we calculate the return for the portfolio. We use the each asset's return times its weights to calculate the portfolio's return. The portfolio returns is showing an increasing trend with decrease on week 5. And we do returns distribution for different weeks. Some of assets have negative returns, but some of them have positive returns. And we do efficient frontier calculation, and the curve is efficient frontier, and the line is tangency portfolio line. So we can see that from week 1 to week 5, we have an overall increasing trend. And we also estimate the covariance change. Here we use the second norm to calculate the change of covariance. That is, use one covariance minus another covariance and take their norm as the change. We calculate 4 changes, and the change is not so large. And then we do portfolio analysis by using different ratios. The first ratio is Sharpe ratio. The Sharpe ratio is the most common measure to analyze the performance of a portfolio. And here, our Sharpe ratio equals to 0.32. And we also use Trainer ratio. Trainer ratio is also a popular measure, and the difference between Trainer ratio and Sharpe ratio is the denominator part. And our Trainer ratio equals to 0.33. And we also use other ratios like information ratio, Sortino ratio, and maximum drawdown. Here, the information ratio is 0.2923. It is less than 1. That means our portfolio is worse than the marketing portfolio, and the maximum drawdown is not so large. That means our return is concentrated. And we also calculate the alpha and beta for our portfolio. Here we have negative alpha. That means our portfolio has worse performance than the marketing average. And then we do cumulative margin and leverage ratio. Our account has positive number over the 5 weeks, and we didn't receive any margin calls, and the leverage ratio has an increasing trend except for decreasing in week 3. Our conclusion. So our portfolio has an overall worse performance than the market since we have lower Sharpe ratio, trainer ratio, and our information ratio is less than 1, and our alpha is smaller than 0. And then we do our campaign model. First, we estimate the beta. The beta is calculated by sigma jm over sigma m square. And here we get our betas and widths. So the overall, our portfolio beta is 0.70484, and we calculated least trimmed square. Least trimmed square is a robust statistical method that we drop the outliers and we prevent they affecting our model. So here is the return distribution for Apple company. Before we do trimmed least square, we have an Gaussian distribution and the range is so large. And after we do the trimmed return distribution, our return concentratedly on the midpoint, on several midpoints. And we also do shrinkage estimation of beta. Here we use alpha equals to 2/3 as the shrinkage estimator, and the formula is listed on the slides, and we get our betas. From the table, we can see that all betas move closer to 1. It means the stock price will move with the overall market. And our portfolio beta is 0.9338. And then we do exponentially weighted moving average. It is calculated as lambda times sigma t squared plus something times square t minus 1 sigma t minus 1 square. This means we need to consider the past information. And the betas for exponentially weighted moving average is shown on the graph. We choose 2 lambdas. One lambda is 0.9 and the other lambda is 0.6. From the graph, we can see if we the lambda of 0.6 has large volatility, and if we choose lambda equals to 0.9, we will get the betas similar to initial beta. That means if we consider more information from the past, like we use a smaller lambda, we will have the betas more volatile. And here is the comparison for beta by using different methods, and we can see that let me see. The trimmed beta, shrinkage beta, and initial beta are similar in value, and trimmed method has the smallest beta among all the 3, which means it gives us lowest return and the lowest covariance of the portfolio, while the EMWA is the most fluctuated one with consideration of the past. So if we want to choose the beta, we would like to choose maybe trimmed beta, and the EMWA is not a good choice. Besides, we can see that the assets USCI has a strange EMWA beta because the other 3 betas is positive and the EMWA beta is negative. Conclusion. Firstly, our initial portfolio beta is 0.78, which is smaller